for me today?
Well, Diane, I have some breakfast cereal, total.
Okay, what are we going to do with that? I thought we were talking about magnetism.
Well, reading the box, it says that it contains 100% of your daily requirements of iron.
Well, what are the ingredients?
Grain, wheat, sugar, honey, salt, vitamin E, preservatives.
None of those contain
no
iron.
No iron. Yet it says right here that it contains all the iron you need every day.
So how do they get the iron in there?
I wonder.
Can we maybe find it?
I have an idea, Diane.
All right, great. What are you going to do?
Well, I was thinking we could put the cereal in a blender along with some water.
Yeah.
And turn it into mush.
Ooh.
Which, if there's free iron in there, we should be able to retrieve it with a very strong magnet.
Okay, let's give it a try. So this is a flake of total, and I don't see any iron in there. I mean, there's nothing. Well, it's got a little.
Is that a flake?
Brownish, yeah. Like, I don't know. We'll see. Chris, what are you doing?
I'm pulling the iron out of the cereal.
Wait a second. Oh my gosh.
Check it out. Look at that. Look at the little pieces of iron.
Oh, wow.
It's hard to estimate how much we'll get eventually.
That is pretty amazing.
That is really amazing. Look at that. Look at it move. Look at it move around the magnet.
That is awesome.
It is incredible.
I guess we should say you have to be really careful with this kind of a strength of magnet, don't you?
Yeah, this magnet is very strong.
Yeah. You know that we don't have any other electronics anywhere.
No electronics, no other iron or steel.
Yeah, that's pretty.
Oh my gosh. Look at it. Look at it.
Look at that. It's lifting the bag up. We know the magnet is not attracting the bag. It's attracting the iron filings underneath. Those are all out of that total cereal. Okay. Oh yeah, baby. Hey, today we want to talk about some different types of magnetism. And the first one's pretty basic. I think most people have experienced it, but maybe you don't know the name for it. So we're going to call it ferromagnetism. And what is that, Chris?
Well, I have an example here. Washer's made of iron, and as you can see, it's strongly attracted to this magnet.
So the washer is not magnetic on its own.
No, but it can be magnetized. The thing about iron and nickel and some other materials is that they retain the magnetism after the field is removed.
Yeah, they can do that. And then those domains inside of there, those little magnetic domains are getting all lined up.
They get lined up, and that's what makes this a permanent magnet now.
Oh, wow. Well, let's show them another example that we found out today about ferromagnetism.
We found out the hard way.
Yeah, we did.
I don't know if you can see this, but there are actually two magnets here, a cube and a cylinder. They're not meant to be together. I put them on the table. Almost a meter apart, and all of a sudden, crash, they came together. That's how strong these things are.
And then here, put it down, but don't, yeah. And me, I thought, oh, well, we can use these to get them apart, and that didn't go real well either. So you can see.
You're seeing ferromagnetism at work. Oh, look at, Diane, the table.
Yeah, there must be, there must be some kind of
metal underneath this
ferromagnetic material.
Ferromagnetic material. Oh, look at it.
Oh, wow.
That's
that was
great.
Cool. All right, but that's ferromagnetism. Let's look at some other types.
And they would be?
Paramagnetism
and diamagnetism.
Yeah, we're going to take a look at those. This is kind of an interesting demo that I've got here. Basically a tub of water and a little tube of water. And watch what happens. But when I put a strong magnet near it, watch what happens. Okay, I'm not going to touch it, but I think you can see that the little boat is being pushed across because I'm inducing an opposite magnetic field. And matter of fact, it doesn't matter which pole I use, it's going to be repelled. So notice I stopped it. Now I'm repelling it with the round magnet, and I'm also repelling it. Ooh, very nice.
Diane, I thought that was really cool with what you did with that vial of water, how you were able to move it with a magnet. Now, the thing about water is it's diamagnetic, which means that either pole will repel the water and make it move. Now, since food is about 90% water, we were wondering if we couldn't affect the motion of some food, like these grapes.
Oh, cool.
So what I've got is a magnet that you used on the vial of water, and I'm going to bring it very close to this grape and see if we can't. Oh, there it goes. There it goes.
Okay, let me get.
Now, I'm going to try to stop it, and I'm using the other pole, and of course, it repels. Now I'm going to stop it again and move it in the other direction.
Wow, so it's repelling the grape regardless of whether you use the cube or the cylinder.
The north or the south pole.
Right.
It doesn't matter. And the same with this, of course, with this grape. Boy, look at that move.
Oh yeah, that's really good.
That's really good.
Yeah.
Okay.
So it's the water inside the grape.
It's the water inside the grape. That's exactly right.
Hey Chris, we've talked a decent amount about ferromagnetism and diamagnetism, but we really need to hit paramagnetism now.
Yeah, we've got a little balance here with graphite at one end and some aluminum samples at the other.
Well, let's see the behavior of the graphite and see if we can figure out if it's ferromagnetic or diamagnetic, because it's one of the two. So let's take a look at that one and see if we can figure it out.
Okay, I'm going to bring the magnet up close to the graphite sample. And look at that. Look at that.
It's definitely being repelled.
Now I'm going to bring it up on the other side and see if we can't stop it.
Oh, yeah.
And one more thing, Diane, we talked about that either pole will repel the graphite, and that's certainly the case.
So based on that, my decision is that that is a diamagnetic material.
Correct.
Okay, good. All right, so the other side you said was aluminum?
It's aluminum.
Okay.
And aluminum is paramagnetic, which means that it's weakly attracted to a magnetic field. So I'm going to bring the magnet up and see if we can't witness some attraction.
Oh, yeah.
Okay, look at that.
Nice.
Now, I'm going to stop the balance, and I'm going to bring the other pole over here and see if we can attract it from the other side. And yes, we can.
Yes, we can.
So a paramagnetic material is attracted by either pole, but very weakly.
So it behaves like ferromagnetic materials, but just not as robustly.
Correct.
Chris, what have we got going here?
We have a known as a Curry point engine.
Okay.
And it's a beautiful example of both paramagnetism and ferromagnetism. At the end of this little copper pendulum is a sample of nickel. Now, nickel at room temperature is ferromagnetic and is attracted to these magnets. You can see here on the end. However, when the nickel reaches a temperature of around 670 degrees Celsius, it becomes paramagnetic and is not as strongly attracted to the magnet. So what's going on here is first it goes in the flame, becomes paramagnetic, falls, but then it cools rapidly and is again attracted because it is once again ferromagnetic. So it goes between those two states quite rapidly, as you can see.
Wow.
Yeah, it's quite something. But it's a beautiful example of the two types of magnetism working in concert.
Yeah. Very cool.